In this lecture, we'll do two examples. The first one is to establish the identity sine alpha minus beta over cosine alpha cosine beta is actually tangent alpha minus tangent beta. Okay. The second one is about the application in electricity. Okay. So let's work on the first one. Basically, establish means you want to prove this is true identity for all the values. Okay, so basically this one want you to practice the formulas you have learned. Okay, but not many for this one. Not many formulas. Now let's look at how we are going to do it. We'll start with the numerator right down here. Sine alpha minus beta over cosine alpha cosine beta. Now sine one angle minus another, we know that will be sine cosine and then cosine sine. Again, this is the way I remember. Okay, and then here is subtraction, so you do subtraction here. First angle is alpha, so alpha alpha. Second angle is beta, so beta beta. Okay, now divided by cosine alpha cosine beta. Basically each value needs to be divided by cosine alpha cosine beta. That's distribution, distributive property. So cosine alpha cosine beta. Okay, up to this far you can do the consolations. Cosine beta upstairs and downstairs. Okay, cosine alpha upstairs and downstairs. What do we get? We get the first one is sine alpha over cosine alpha. That's basically tangent alpha. Exactly. Okay, and then subtract sine beta over cosine beta. That's tangent beta. Alright, so we are done easily for this one. Now, the second one is voltage through a certain wire. Is E equals 50 times sine pi t subtract 3 pi over 2. So here is the thing we want to do. This is given, and then we want to express the expression, this one, in terms of cosine, because here is in terms of sine. You know, sine, cosine, here is sine, here is cosine, then we go to do cofunction. Okay, so if you remember, that will be what? Sine theta is actually equals cosine pi over 2 minus theta. Okay, that's the formula we're going to use. Alright, and then what is the theta here? You see, sine, you treat this whole thing as a theta. And then here is, so you want to put into this formula. Then you are done. Okay, so let's see how to apply this formula. Alright, now you want to write as E, the voltage, equals 50 sine pi t subtract 3 pi over 2. Now 50 you copied, you cannot do anything with that. And then you directly write cosine. Cosine. Now, pi over 2 is always there. Pi over 2 is always there. Subtract. Subtract what? Subtract this angle. Okay? So pi t minus 3 pi over 2. Okay? This big quantity. Again, this big quantity is theta. You may not get used to it, but you know, that's it. Okay? Yeah, then you want to simplify that. This big quantity is theta here and theta here. Replace theta with the big quantity. Now, what do we get? 50 is there. Cosine comes out. Okay? Then you will have a pi over 2. You copy that. Minus pi t. This minus works on both. Okay? So minus goes to this one and minus goes to this one also. Distributive property. Negative, negative comes to be positive. Okay? 3 pi over 2. Alright. What do we get? You know, pi over 2 is basically what? 1 pi over 2. There is a 1 in front of it. Okay? Keep going. You then have what? You then have a cosine. Cosine. Negative pi t. Negative pi t. This is 1, this is 3. Together is what? 4. And 4 divided by 2 is what? 2 pi. So plus 2 pi. Alright. Yeah, again, 1 plus 3 is 4. Divided by 2, you got 2 pi. And cosine has the period 2 pi. So then you then have a cosine negative pi t. Okay, because this is what? Period. You want to period. Okay. Now, cosine is an even function. Okay. Then what? Then you will have a 50 cosine pi t. That's it. Because from here to here is what? Is because cosine is an even function. Okay. Sine is an odd function. So you cannot really do this for sine. If here were sine, this negative sign comes out. But here, cosine is an even, so negative sign just disappeared. Alright? Okay. Please review this lecture. I'll see you next time.